VastSky is designed for cloud environment. VastSky is supposed to be used in cloud system. VastSky gives you a ordinary plain logical volume just for virtual machines. You can make that logical volumes from lots of PC servers with lots of disks. With this VastSky, you don't need expensive high-end storage anymore. But this storage system is made from cheap PC servers and cheap disks, but it is reliable and scalable, and this system has good performance. Before I start to explain about the design of this system, I'd like to announce that the code of VastSky is just opened at this site. You can find the source code on sourceforge.net. But I'm sorry, this code is not finished yet, so I think I need some more weeks to finish the work. So after that, you can use it with XCP. Now, let's start to explain the basic design. Basic concept is very simple. We have to make the sorry. Before I started this project, I just came up with a very good idea. If we achieve the idea, we can get reliable, scalable storage system. So how can I explain how can I make that storage system? This picture shows you how we should make a logical volume from these physical disks. Right up to the side of the disk is the logical volume, which is I want to make. This logical volume is made from right side 16 physical disks. Logical volume is made from either logical volume is made from this picture. In this picture, this logical volume is made from 3 mirror disks. This logical volume has 3 mirror disks. Each mirror disk has 3 physical disk chunks. So chunks. This system every physical disk is split into small chunks. So and logical volume is created of these chunks. Actually, the current in this current implementation, the size of chunk is 10 gigabyte and 10 gigabyte. So so this this logical volume will be made from a lot of small physical disk chunks. So why this in this implementation works with this implementation? Why that gives you good performance? One reason is first, all the I operation to the logical volume will be done in Linux kernel. With every operation will be done in the Linux kernel. So the speed of the I operation is the same as the ordinary Linux kernel. And next, if you define 3 disks right here, actual disk chunks will be distributed all over the physical disks. So these read-write operations will be distributed all over the physical disks. So you can use all the ability that these physical disks have. And this case, for these logical volume is very heavy loaded, but in many cases, some of them are not accessed so heavily. So in this case, upper 2 logical volumes can use the ability of the physical disks. All of the ability can be used. Andこれにしようかな。And I'm talking about the recovering the mirror disk. Recovering a disk works efficiently. Before the explanation, I will explain how the recovery operation will work. Mirror disk is almost same as a regular RAID 1 system. The difference is 2 points. One is usually mirror disk doesn't have a spare disk. That spare disk is assigned when one of the physical disks has broken. This is the difference. One of the difference. And the timing. Second difference is timing to assign the spare. In the system, there may happen to be lots of mirror disks that need to be recovered. In that case, VastSky manage the load of the system. So load the system. So now keep the VastSky try to keep the load not to become high. So now I'll explain the why. Now explain why recovering the mirror disk works fast. That's because this, I think, this picture shows why recovering the disk will work fast. In this case, that physical disk has broken. In this case, this physical disk has 4 chunks, and top chunk is assigned to this yellow logical volume, and second is assigned to the top logical volume, and last one is assigned to this logical volume. So VastSky assigned detects this physical volume is broken. VastSky assigns new spares like this. So you can see these spares are assigned allocated in different physical disks. So recovering operation will be 3 different operations will be working simultaneously. So it can be that. So the recovery operation will be done in a short time. And if third chunk is assigned to any logical volume, so you don't need, you just leave this chunk untouched. And I talk about scalability. This design gives us a scalability because every access to the logical volume is each volume is working independently. Because each logical volume doesn't have any metadata which should be shared other disks, other logical volumes. If you use distributed file system, some people want to use distributed file system for that cloud platform, but if you use distributed file system, it has a metadata, so every access data might before every access to the data, metadata will be referred. So the metadata will easily become a bottleneck of the system. But VastSky doesn't have such kind of data, so we can make the system scalable. And this system, servers can be added in the system dynamically. If you have in short of disk space, you can add server. You can add server anytime. Next, I'll talk about how to set up VastSky. VastSky is just a software to control storage, control physical disks to make logical volume. So VastSky itself doesn't work. VastSky should be installed with VM management software such as XCP, and VastSky doesn't take care of network redundancy. So this feature should be implemented outside the VastSky. You can use a bonding network device, I think. And I expect hardware health check software or something will be will exist, and I hope this health check program tells VastSky which hardware, which server or disk has broken. So if once VastSky accepts such notification, VastSky starts rebuilding the logical volume. And the current implementation has a little problem. VastSky has requires HA cluster software. Requires HA cluster software because this program is not this software is the core of this thing. So if VastSky stops, when VastSky stops, this class software detects that problem and restarts the VastSky. It is required. This is the API. VastSky has a lot of APIs like this. VastSky API is two types. VastSky has two types of API. One is XML RPC, and the other command line interface. XCP or hardware check program can call these API to control VastSky storage. You can define a logical volume and attach a logical volume to a certain server, or detach the volume from the server, and you can notify which disk is broken, and also you can add a new server with a disk, and you can delete the server from the system. So we have a lot of things to do. We are now integrating XCP, integrating VastSky into XCP. We are just working on this. Maybe it will be done soon. And I'd like to improve the scalability. The biggest problem is, the biggest issue is, I want to make the system network topology aware. So why this is important? If you want to get a good performance, physical disk chunk should be allocated from the logical volume, from the server, which has a logical volume. So as far as this physical chunk has to be allocated as near as the logical volume, so logical can work fast. So with this, I also asked XCP should network topology aware. XCP also take care of this allocation to allocation. If you want to restart a VM, the VM should be should be created on the server as near the original position that virtual machine was working. And I also think about implement new features. Logical volume expansion. This will be easy to implement. And I'd like to implement a snapshot feature. I have several ideas to implement this feature. The easiest way is use a DM snap. This DM snap is a Linux kernel module, so just it's easy to use, but it is most of people think this works slow. I think that's true. And another way, second idea is implementing a completely new, make a completely new implementation. But this approach will take a long time, right? But it will be fun. And third idea is to use OCFS2. If you make a make a volume for virtual machines on the OCFS2 file system, you can get a snapshot features, and also you can get thin provisioning features as well. If you create a logical volume from this physical chunks, and then make a そうね、make a volume. It is just a file. Make a file, and that file assigned to the virtual machine. You can get rich features. You can get rich features that OTFX has. But this approach has a little problem. This approach has a little bit overhead, needs a little bit overhead. And others, I also have another idea to implement. I'd like to implement a shared disk. But shared disk is not so easy as I thought. You may think, what's the problem? If you want to implement shared disk, recovering it has a problem when it has to rebuild MD device. It have to we need access control between rebuilding and write access to the disk. So we have to take care of that condition. And we have to implement this feature. This feature will be interesting. If you have snapshot feature and shared disk feature, you can implement fast virtual machine deployment mechanism on those features. You can make a logical volume from this red volume as a shared disk, and you can use a snapshot feature with shared disk. VM can a virtual machine can if a virtual machine write a data, the write data will be stored in the core device, copy on write device, and this side of virtual machine may write another data. That data will be stored in this core device. If you implement this feature, deploying the virtual machine will be done in a second, I think. There are a lot of other things. I want to implement these things too. I think the last one is, I think, very important, but a bit of difficult. If we can bus manager, VastSky, we can be able to run in one virtual machine. XP can handle the VastSky as a regular virtual machine, but it has a big problem to implement it because the information the information to create the disk, create the logical volume which VastSky uses is stored in the disk volume. So I need some trick to implement this feature. Then now roadmap. Just first version release is scheduled. The first version will be released in this coming June, and I'm gonna implement the only basic design. So the rest I have to do is exhibit implementation and make it stable and write a documentation about how you can use it. And second version and after, we haven't decided. We haven't done nothing. We haven't decided anything about it. I'm thinking which should we implement first. Thank you.